So let's talk about the limit as x, y approaching the origin, and we have the absolute value of x plus y raised to the power of x squared plus y squared. And because we have the x squared plus y squared, and xy is approaching the origin, so maybe it's a good idea to use the polar coordinate, right? So let's give it a try. Recall x is equal to r cosine theta, y equals r sine theta, and x squared plus y squared is r squared. And when we have the limit as x, y approaching the origin, we just need r going to 0. And some people might say it's just r approaching 0 plus. It's okay though, in my opinion, because r can be negative in the polar coordinate. Depends on the convention, but we'll take it as okay. Continue, we have the absolute value. X plus y is just this plus that, and because they both have r, I'm going to factor that out. And then raised to the power of r squared now. Okay, cool. Now, if we put 0 for this r, 0 times this, we get 0. And if we put 0 in here, we get 0 squared, which is 0. And we have 0 to the 0's power. Now what? Well, unfortunately, this is the indeterminate form. Even though we just have r approaching 0, but cannot draw any conclusion yet unless we do more work. This could be 1, it could be 0, it could be e, blah, 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 right? But maybe that's just distributed exponent because we have r times this. So absolute value, I still maintain the absolute value because we usually don't want the base to be negative when we are talking about exponential stuff, yeah? This raised to the r squared and then times absolute value cosine theta plus sine theta raised to the r squared power. I will tell you, when we have r approaching 0 of this thing right here, you will get 1. You can just do some calculation stuff for that. Okay, but now the trouble is this. Can we draw any conclusion right here? Unfortunately not, because we still have the r, so we still have the theta. Right? This expression is still depending on theta. But can you say this right here does not exist? Well, no, because I've done examples in the past that sometimes even though you still have the expression involving theta, sometimes the limit exists, sometimes the limit does not exist. So it's unfortunately the polar coordinate just doesn't do it in this case. We are going to find two paths that have different limits, right? So let's get to work. Because we have x, y approaching the origin, I'm just going to say along y equal to 0, so that's the x-axis. So we have the limit as x approaching 0 here, and just absolute value, that's 0, so just x. That's 0, so just x squared. I told you that was equal to 1. Earlier I used r, right now it's x. But I will still do it for you guys real quick. The first case is the limit as x approaching 0 plus, right? If it's 0 plus, then the base is positive, absolute value doesn't matter. Yeah? If it's 0 minus, then you have a negative, but that's worry about that later. Anyway, so this right here, we get the base, change that to e to the ln x power, times this power, and then take the limit as x approaching 0 plus. Focus on doing the limit right here. So e to the limit of x approaching 0 plus. We will get indeterminate form of 0 times negative infinity. I'm going to bring the x squared down, so we get ln x over 1 over x squared. And for the convenience to take the derivative, I'm going to write that as x to the negative 2. And then right here, we will get negative infinity over infinity, still indeterminate form, but we can use L'Hopital's. So we are looking at e raised to the limit x approaching 0 plus. Top, we get 1 over x. Bottom is negative 2, x to the negative 3. multiply the top and bottom by x to the third power. This and that cancel. And we see that's e to the limit of x approaching 0 plus. This and that cancel. And we have negative 2. But if you have 0 plus here, it's x squared over negative 2. But 0 plus here is just 0. So this limit is just 0. But e to the 0, so it's just equal to 1. Alright? So in fact, when we have x approaching 0 plus, we get 1. But you know, if we have the limit as x approaching 0 minus, because we have the absolute value, the function is even. So this thing will be the same as that thing, for sure. It's even. Yeah, this is an even function. Perfect. So we got 1 from here. This will also be 1. So the limit is indeed equal to 1. Let's try this. Along, I'm going to make the base equal to 0 all the time. So I'm going to say along y is equal to negative x. This is still approaching the version, alright? So in this case, I'm just going to say y is negative x, I will still have x. Let me just look at it like that. So x is approaching 0. And then absolute value of x minus x raised to the x squared plus negative x squared power. Now check this out. This is the limit as x approaching 0. X minus x, it's a solid 0. It's just purely 0. Alright? It's not like this. When you have x approaching 0 like this is like 0.0001, right? You can think about it like that. But x minus x, it cancels it out right away. You can still have the absolute value, and then the top, this right here is 2x squared. But if you work this inside out, because the base is always equal to 0, raised to whatever power, you will get 0. Just ignore that. This is the limit as x approaching 0 of 0. So for this one, you get 0. These two limits don't exist. These two limits don't agree. That limit does not exist. Alright. Okay. So I did that for you guys. Now you do this one. Try this on your own. What if we have the limit as xy approaching 0, 0, but we have this. I switch the base and the power. X squared plus y squared raised to the x plus y power. Go ahead, leave your answer down below.